Hello and welcome to Swerve Drive Training. I am Josh and I'm going to be showing you guys how to make an assembly just like this. I'll be going through how to logically lay out the tubes and belly pan and then create assemblies from that so that they will be robust and be able to be easily adjusted throughout the season. So starting here in a brand new document, as if this was the beginning of the season, we're going to start simply by sketching a top view of the tubes. So grabbing here a top view, I'm using center rectangles because I want this to be nice and centered on the center point, because for the most part in this case we're going to be using a symmetric design, although it may be more of a that's a square rectangle, just odd rectangle. So if this is our outer tube, in our last season we used a 29-inch tube, so for now that's what we're going to use. In general, you just have to make sure that the outer dimension adds up to no more than 120 inches, although that changes year to year, so this is not consistent. Now the tube we're using is 1x2, so from a top view we're looking at 1 inches, and that is the same over here. So now what we want to do is we need to figure out where the holes need to go in this corner. There's actually a bit of an offset, you might say, on the tubes, and we have to figure out what that offset is, where we then have our first hole is somewhere around here, so we can dimension it off of this wall as 0.5 because it is halfway up that, and then it is some dimension here, and then this is some dimension here. So how do we find those dimensions? So I'm actually going to go over to our assembly, and I'm going to use MKCAD to pull up the Mark IV Swerve. So MK4, and here we go, Falcon 500, Falcon 500, correct, that's exactly what I want. And it should pull up. There we go, just takes a second to load it. Okay, so these are the holes I'm talking about. You'll see that they're offset, that there's a min distance of 4, but we should have a center distance of 0.5. And then what really we want to see is this. Where is the placement on these? So if I grab here and here, look through our distances. So if we look here at the center axis and we look at the y direction, we can see it's negative 1.5. And this is to this straight line. So if we go another 0.5 gets us to the center, and another 0.5 gets us to the edge. So we can see that that's a total of from 0 to the far out edge is 2.5 inches. So we can take that dimension, go back to our part studio, go back to our sketch, and we can see that it's 2.5 inches. So if I was to say that this is a 1/2 inch from the wall, this would have to be 2 inches. And the same would be true over here, although we're not going to dimension that. We're just going to use relationships because these are equal to each other. And for now, actually, I'm not going to sketch these points. Now, what I want to do is the rest of the points. Let's look at what is the distance, and close MKCAD. What is the distance between points? So that is a 1 inch parallel distance. So I'm going to come over here. I'm going to use a linear pattern. Oh, and I forgot to count how many were over there. 1, 2, 3, 4. We need 4 of these linear pattern. Just grab that. Change that to 4. That's the 1 and a 1 inch distance. And there you go. There's the 4 points that we need. Now, I want these over here, and I want them in all the corners. So what I'm actually going to do is I'm going to use mirrors, but to do that, I'm going to first put in some reference lines. So I'm going to put a reference line across there. I'll go find this nice center point, put a reference line here, escape, and start that again over here. Okay, so now we have nice reference lines that will always be centered no matter what our dimensions are. Start by mirroring this. Grab there, select that point, point, and point. And good. I'm going to do another mirror using this line. And I'm going to just use a box selection. Deselect, reselect. There we go. So we're going to deselect and reselect and box selection again. So now we have all of this. So this gets us all of our corners are nicely defined and has all our hole positions. Now for actually making the tubes themselves, we're going to use the extrude tool, and we're going to deselect because it selected everything. What I actually want to do is select this, this, and this, because this is where the actual tubes are. Now, as I said before, these are actually 2-inch tall tubes, but I want this to be centered on that point, so I'm going to use the symmetric tool. This is just a good practice in general. Okay, so now we have the parts, but obviously we're using tubes, not solid chunks of aluminum. So the quickest way to do this is to use the shell command, and a wall thickness of 0.1 inches I do believe is accurate. This would be something that if you were actually in a meeting, you'd go grab calipers and double check. So I'm going to select all of these walls. And then now we have tubes. But now we want to add the holes into the top and bottom. So we're going to use all those points that we made as our hole locations. So I'm going to select these points. Now what we're going to do is I'm going to change this to a simple blind, not blind, I wanted it to be through, and it's for diameter. For the bottom one, we actually want to have a through hole that the head of the bolt can go through, and so we're doing 1/4-20 bolts. If we go pull up McMaster and I go look at screws and bolts, socket head type screws, and I'm going to go grab 1/4-20. It doesn't really matter what I do. 1/4-20 by anything. So 1/4-20 by anything, and then we go look at the diameter of that is 0.375. So that's the diameter that we have to fit through. So we want a little bit bigger than that. So I'm going to do 0.4 inches. Okay, and so you can see we have that going out the bottom. Just a little bit bigger, gives us just a little bit of tolerance there. I'm going to select the rest of these points. Okay, that's simple. Now for the upper side, we don't want it to be a through hole. We want it to be a through hole for the thread itself. Now this is actually really easy because we're just going to use simple, and we're not going to do custom this time. We're going to do an ANSI, clearance, 1/4-20, and a free fit. Or, yeah, free fit, that works. And now go select these. I already selected the correct direction. If it's going the wrong way, you can hit this and it will reverse which way it goes. Select it correctly for me so I don't have to. And then let's get all this selected. And there we go. That's all the holes in the tubes. The tubes have been defined. And the beautiful part about this is they're all defined as nice and centered on the origin point. So it makes it really easy when making assemblies. So that's very nice. So I'm going to actually go close the sketch so it's not annoying. I'm going to hit P to hide the planes. Now one thing is you'll notice these are all different colors, and also we haven't assigned any material to them. This is the best time to do that. So I'm going to grab that. I'm going to assign a material. And this is going to be 6061 aluminum. That is just a very general aluminum, and almost all the aluminum we're using is that. On rare cases we'll use different, but rare cases. Okay. And then I also want to edit the appearance. I'm going to make it kind of darkish because why not? Makes it look nice. So now we have this and we're ready to go make our assembly. am also going to go through and name these. So this tube here, if I look there, that is the back. Okay, we're gonna look, and I'm looking up in when I say look, I'm looking up here at this here quadrant thing, and that's how I'm defining this as the back. This is important because later on down the line, when let's say we're inputting some sort of subassembly, we might have mounting holes or bearings mounted in this or different things. So knowing which tube's which is going to be very important. Tube, then that is the left tube. And that leaves that to be the right tube. I'll rename that. Okay, so that gets us our naming. Their material's been changed, and everything's been defined. And also, if you end up modeling extra superstructure, so like in the last season, in the 2022 season, we had 2 beams running up and down. This is where I would add that as far as modeling goes, because that builds relationships. That is, you're building with intent, you're designing with intent. At some point, we'll also come back here and design the base tray, the belly pan. But for now, let's go to the assembly, and it still has this in it, which is not a problem per se. We will need that. So I'm actually going to grab the whole part studio, do that, and there we go. Now right now nothing's actually defined. Go Control Z. What I'm going to do is I'm going to put all these in a group. Okay, they're all now grouped, and then you see they'll all move together. Now I'm going to hit Control Z, move it back, and I'm just going to fix one of these. Okay, so now these are fixed, none of them can move, and we're ready to start making our assembly. Okay, it's going to be as simple as grabbing one of these holes and grabbing the same hole in one of these tubes. There we go. If it didn't come in the right rotation, you might adjust the rotation there and flipping it up and down with this. You shouldn't need it if you selected the right points, but here you go. So now we're going to do that 4 more times. So now I'm going to go grab 4 more of these. I'm going to actually just right click and copy, and Control V, Control V, Control V. And again, fastened mate, select corner. I'm going to go there, and here I did have to rotate. And again, we're going to do the same exact thing. And I have to rotate. There we go. And again, same exact thing. And rotate. There we go. So now we have the entire chassis roughly together. Now I am going to want to add all the screws. So here we have, what we end up doing is we just drill out these holes for 1/4 20, and we use through screws. So I actually want to take and measure the length of this, which is 0.288. So I'm going to want to have enough room for a nut. So I'm going to actually use 1/2-inch screws. So for that, I'm going to use the standard content library. I go here, insert standard content, ANSI inch, bolts and screws, socket head screws here. And then here we go, socket head cap screws. So we're going with 1/4 20 because that's usually what you use. Drive type hex, length 1/2 inch, threads 1/2 inch. Okay, so we're going to take this. I'm actually going to select this point first and just hit insert. And there you go. It's already even made it up if you select that point first. If not, you can just use a fastened mate as normal. But now I want to put that on all of these, and that would take a long time to select those points. So what I'm actually going to use is the replicate tool. So we're going to do this. I'm going to select instances, so that would be in our case the screw. It already auto selected the mate at once, and then we're going to select what faces we want it to repeat it in. So I'm going to select this face, and it's going to find all the similar type holes and place a bolt in that location. So I do that, and do that. So now you'll notice I have bolts everywhere. All the bolts are in. And I only actually had to mate up one. And it makes it really nice and clean over here in the feature tree. So next, we're going to go insert now, instead of bolts and screws, we're going to go nuts, machine screw nuts, yada yada, quarter 20, good. As far as location goes, I'm going to select, I actually want to hide this cap screw, and I'll hide the replicate, why not? So that I can select that point to insert this nut. There we go. And then I'm going to unhide these. And now I'm going to replicate again, selecting the bolt nut as the instance. And for faces, I'm going to select this face. Wait, no. And for faces, I'm going to go hit face and select that face. And there we go. So we're going to match faces. We're going to go over here, select this face. Go over here, select this face, and go over here and select this face. And now we have all the nuts and bolts all mounted up. And I'm going to actually hide all these mate connectors because those are ugly and I don't want to see them. So we now have the chassis frame rails, the Swerve modules, and nuts and bolts and everything on all defined. Now what I'm going to want to do is put on a belly pan. Okay. Now for the belly pan, I'm going to steal some dimensions because I want to use this as my guide. So I want to get this dimension till here. Let's see what that is. 4.75. And then let's grab what is the radius of this. Radius of 2.5. Okay, so that's easy enough. And we're going to go back to Part Studio 1. We should rename this probably at this point to chassis tubes, frame. Okay, now we're going to use a bottom view. Okay, and we're going to sketch. This time we are sketching on the bottom of the tubes, not on the mid plane. And I'm going to use a center rectangle, and it is going to end up going to these corners. So I'm referencing off of this corner, these two top left corners, so I can get it right up to the edge. And now that's referenced rather than dimensioning it. So if I change dimensions, it won't break anything. And then I'm going to make corner marks here. Okay. And I said, what is it, 3.75 or 4.75? And I said 4.75 from there to there. And we're going to use an equal relationship here to define that because we don't want to add any unnecessary relationships. I could use a fillet later on in this corner, but what we should do is use a 3-point arc and just put it here so it's easily definable. And it's going to be a radius of 2.5 as we said earlier. But this isn't defined because what I want to do is I want to make sure that it's tangent to these lines. So tangent basically just means that it terminates that collinear to that line. So now we have this and we're all fine and dandy. We got our corners defined. See where it's coming up to. I'm going to use the mirror tool again to define it in all the corners. So we're going to make center lines. And the reason I like using the mirror tool rather than say dimensioning something or redoing it is it's an easy way to add symmetry and whatnot, so that when I change dimensions, everything's still symmetric and as it should be. So mirror, selecting line, and there, and there. Okay. Then a mirror again, select line, and there. Okay, so now we have this, and this is our base plate. As far as holes go, we're going to go here. And I'm going to dimension this as 1/2 inch off of that. Use the linear pattern. Here I'm going to change that to 1. Didn't they make a way to make this symmetric? I'm going to make a 10. No, that's too far. We're going to make it 6. Too little. 8. Could fit another one. 9. There we go. That's just right. Okay. So now I am going to add another reference line, which we didn't do earlier, so that I can mirror this along that line. Grab all of these. We'll say if I had thought about it, I could have done this at the same time that I was mirroring everything else, but I didn't think about it, so you know. Then start the mirror all over again. And now we're going to go here and selecting these all. One thing I like about doing points and then using the hole tool is that it makes it very easy to post design the diameter of the holes. Whereas if I just like define a bunch of circles and then define their dimensions, I'd have to go back into the sketch and figure out where I define that. Select these like that, these like that, and this like this. And there we go. We got all the holes we could ever want. Okay. So now I'm going to use the extrude, and I'm going to select this area here. Now I'm going to make sure it says new up here, because I do want a new plate. We're going to do this as 1/8 inch. No, not 1/8 inch, 0.125 inches. This is a new part. It's going down. You know, make sure you get the direction right. Don't want it going up into the part. Now we're going to use the hole feature. We're going to unhide this because I want to be able to select these positions. So for this, we're actually going to go and not do ANSI. We're going to do custom, and we're going to do 1.3. So it's just a little more than 1/8 of an inch. The reason for that is we're going to be using 1/8 inch pop rivets. And so let's go and select these points. Okay, we can see it's working. Use this tool. Use this tool. Okay, don't want these. Okay, and so that's cutting through. So there's a bunch of broken vertexes there. Why? Oh, because when I hit the extrude, that did not go through. Let's go back and fix that really quickly and select that plane there. Okay, so now that is fully extruded, and then the hole feature is all good. Okay, sweet. Now we're going to do another hole feature going the other way. Let's make sure it's going the right way. And so yeah, we can see it's doing a hole through. Now it's going all the way through. I don't need it to go all the way through. I only need it to go through one side. So I'm going to change it back to blind. And a depth of 1/2 inch works. It's not going to interfere with anything, and it's only affecting the tubes. So let's select all this. Let's select all this. Select all this. Select all this. Okay. Then we're going to deselect the ones we didn't want. There's all these selected. So now we have all these holes in the tube. Nice and quick. Sweet. Hide this sketch because I don't need to see that anymore. Now again, we're going to assign a material to this. A lot of times this will actually be polycarbonate. Polycarbonate. There we go. And as far as appearance goes, what we'll actually end up doing is leave it roughly this color, but change the transparency because it's polycarbonate, which is clear, just a little bit lower so you can kind of see through it. We don't want it to be too light. And then let's go to our assembly. we're going to insert that part. Current document, this here is part 5. Oh, we did forget to name it, which is our mistake. Go back and do that. But let's select one of these and position it. And we can see the positioning is correct. Nope, that's not what I wanted to do. And check. Sweet. So this is positioned correctly. We're going to then want to go use MKCAD to grab a pop rivet, configurable rivet. So we're dealing with flange width, flange height, grip length, and diameter here. So this is 0.125 for us. For the diameter, the rest of the dimensions we can go like find on make a master. Just search rivet. We use 1/4 inch rivets, 1/4 inch or 1/8 inch rivets. I mean, 125 1/8 inch. We can go find a standard aluminum domed 1/8 inch, and so we're going through an 1/8 inch plus 0.1 inches. So we need at least a grip length of 1/4 inch. So grip length of at least 1/4 inch. So this here is 0.188 to 1/4 inch. This would be a good one to choose. And this gives us a 0.04 inch height and a 0.262 height, and then a 0.4 inch length there. So that is a, what did I say? 0.262. 2. Flange height was 0.04, and grip length was 0.4. So let's insert that. It should go right to the center point. When it stops processing, there we go. Let's close MKCAD. Let's grab that and yank it over here. So I'm going to use a fasten mate on that to right there. Flip that to get it faced in. See, there it is. And now we're going to use the replicate tool. Grab that instance. Grab face. And there we go. And it should take a second to process. And throw them all up. If I accept. There we go. Yeah. And there we go. We have all the rivets in the bottom. Okay. So now we're going to want to do an electrical layout. As far as laying out electrical goes, this would be usually a conversation that you'll have with someone who knows how the overall goal is. For now, because this is just a test chassis, we can kind of lay everything anywhere we want. So we'll focus on making sure we just get all the electrical components in, put them as we wish. So first of all, we're going to want to make sure we have a battery. Then we're going to want a main circuit breaker. Mount. We're going to want a PDP, but not this one, because nowadays we use the Rev PDP. Yes, I want the breakers. And then we're going to want a Robo Rio, a robot radio, and there are simplified versions of these if we start running into processing issues, which are nice to have, and they still have all the mounting holes in them. But for now, we don't have to worry about that. So I think this is what we'll worry about for now. Okay, so we're going to mount up the Robo Rio first. To do this, we're going to use this here Robo Rio mount. There are many versions of mounts just like this. Make your own if you want to make it nice and pretty. We're just going to quickly mount this up here. And get that. Okay. Now let's get some dimensions off of this. Let's get rid of these. Let's get some dimensions off of this, and we're going to get the distance from here to here, which is 6.784, was it? 74 by 7.061. 7.061. Just putting these up here so I have these easy to reference. Now if I go to chassis frame, I'm going to go and I'm going to create a sketch on top of this plane. It's going to be pretty simple. Just centered on the center point. That's exactly where I want it. I want it to be 6.784 by 7.061. Okay, now we're going to do it. We're going to put holes through these corners. Now for the actual dimension on the hole, we could go use like the ANSI number 10 clearance, because we're going to use number 10, but actually what we're doing is not just number 10 bolts and nuts, we're going to use riv nuts. So if we go here and to find this, we just search riv nut. Just grab your riv nut. For us, we're doing number 10 by 10/32, and our material thickness here is 1/8 inch, so we're going to select the first option, and there we go. So now our dimension is 0.296. So instead of this, we're going to go custom 0.296, and we can pop those holes through. So now we can go to our assembly, and what we actually want to first do is put in one of these riv nuts. So we're going to go download this file, save that, and then import that file. Take a second. Uploading in progress, translation complete. Okay, so now we have this part, and we can go into here into this assembly. We can take and insert this part. Go ahead, do a fasten mate. Not what I wanted to select. There we go, selecting the outer circle and selecting this. I'm going to flip it, and there we go. Now we use our replicate tool, and the really nice part about using the replicate tool here in this case is when I go through and add more parts for the rest of the electronics, it will auto populate them. Get rid of that. Now I want to do this. There we go. And it should auto populate. There we go. And now we can go ahead and take our mount, select this point and this point, solve. Say we got the wrong. So that dimension is correct. Did I measure something? I might have measured something wrong here. Oh, no, that's made. .944. I guess I did measure something wrong, so we just go back and adjust that dimension. .944, I believe it said it was. And we go back to the assembly. And there we go, everything's aligned properly, riv nutted in place. And then let's go ahead, insert standard content. Number 1032. No, we're actually not doing nuts, we're doing bolts and screws, socket head, cap screws. Now 10/32 by is this length is 0.4, so we'll use 0.5, that works. Select this here, insert, wait for it to load, and hit check. And again, use the replicate tool, this, parts, faces, okay, and there we go, we got all 4 screws in. And we're going to go through and do the rest for each of our electronics. So there's those mounted somewhat logically. Then we put the battery here, kind of centering the weight to the right. And the radio, these here are more difficult to mount. So the radio, you'd have to find some sort of bracket similar to this one for the rubber Rio. And then for the battery, you're going to have to design some sort of bracket, either sheet metal or otherwise. This is one thing, is take your time, do it right. But for now, I'm just going to quickly place it just for, not the place I want it, just for aesthetic sake, where you're going to end up wanting it. Yeah, using that and that. Rotate that, flip, and rotate. Okay. And this would be placed somewhere around there, but flipped correctly. Okay, so at this point, we have a full chassis that has all the holes, mounts, bolts, nuts, etc. What's really nice is this is really easy to configure. I can very easily go back in time and say, hey, I disagree with myself. This needs to be a 25-inch chassis by 30. I can update that. The only thing that will mess up is these here, because we did this number based, which might get weird, but it still should work. And you might have to reposition your electronics, but it is what it is. I go here to my assembly and everything has updated. All my stuff is positioned, located, etc. So that's really the beauty of this, is that it's a really robust way to lay out how you position it. I'm gonna undo that. Okay, it's really robust, and it allows us that we don't have to worry about this part, the main chassis, falling apart in the assemblies down the line. Okay, hope that was helpful, and hope that you learned a few things along the way and were able to follow along. If you have any questions, feel free to PM me in the Discord, or comment below, I guess, as well, if you're not on the team. Thanks for watching, and goodbye.